Alright class, today is the last video, and even though my voice is hoarse, I'm going to go ahead and record it. We're talking about factoring, and we've been factoring simple polynomials, simple quadratics, but now we're actually going to factor a little bit more difficult quadratics, and that when the number in front of x squared is not 1. So that adds a little bit more difficulty to it. Before we start factoring, let's take a look at a simple a problem. Let's say I want to multiply these two together. So in order to multiply these two together by a distributive property, I multiply the 2x times the 3x. I multiply the 2x by the 1, and then I go ahead and switch it up and do the negative 4 times the 3x and the negative 4 times the 1. And when I simplify all of that, I end up with the answer of 6x squared plus 10x minus 4. Well, in factoring, you know that we work backwards. So we start off with something in this form and we work backwards to get to this form. And so we had it done when there is no number in front of x squared. Now we're going to work with it when there is a number in front of x squared. But in general, we have a pattern that we see, that the numbers that we multiply by to get 6 are the first two terms of of each binomial, and the numbers we multiply by to get the negative 4 are the last two terms of each binomial. But the question is, how do we get this middle term? And that's the tricky part, because that's the part that there is no exact formula for. But we can we can basically test, check and test any combinations that we think of. So first and foremost, let's take a look at the general form. So if I have two numbers, a1 and a2, another set of two numbers, c1 and c2, that work together the exact same way as before, then that in order to get that first term, my a, I multiply these two numbers together. And in order to get my last term, my c, I multiply these two terms together, the c1 and the c2. So in order to work backwards, all we have to really do is try and figure out what are a1 and a2 that will give me my a, and what are c1 and c2 that when I multiply them, I'll give me my c. And those will give me my a and my c, and then I'm trying to figure out which combination will give me my middle term. So let's take a look at an example. So let's say we have to factor this expression. And in this expression, our a is 2 and our c is 5. So in order to figure out what two numbers multiply together to give me 2, life is easy, because the two numbers that multiply together to give me 2 are exactly 1 and 2, and the two numbers that multiply together to give me positive 5 are either negative 1 and negative 5, or we just switch them around, negative 5 and 1. Well, which of the combination will give me the negative 11? I know that a1 times 2 will give me 2, and I know that negative 1 and negative 5 will give me negative 5, but which combination will give me a negative 11? So before, when we were solving simple problem, we did a little dizzy diamonds, a little x. Well, now that we have more difficult polynomials, we're going to do a big diamond called, well, I call it the big X. Instead of a little x, we're going to do a big X. And we set it up like this. And we're trying to use this to test to see which ones work. So since my a is a prime number, which means it only has two factors, life is easy. All I have to do, there's only one pair of numbers that multiply together to give you 2. That's 1 and 2. Okay? And then because 5 is a prime number, and there's one set of numbers that multiply together to give you negative 5, and that's 1 and 5, negative 1 and negative 5, or positive 1 and positive 5. And we could have used positive 1 and positive 5, but remember we have a negative 11, so you can't get a negative 11 from a pair of positive factors. So to test to see if this combination will work, i.e. if it will give us our negative 11, using the big X, we slide down. When I slide down, 1x times negative 5 is negative 5x. And then when I slide down, 2 times negative 1x is negative 2x. When I add those two together, will I get my negative 11x? No, I won't. So that means that this combination or order is incorrect. So I can change either these two or I can change these two to come up with to try another combination. So what I'm going to do is I'm going to change it. And instead of changing this, I'm going to change it from negative 1 to 5 to negative 5 to 1. And so now when we multiply it down, we slide. 1 times negative 1x is negative 1x. And negative 5 times 2x is negative 10x. And when I add them together, I end up with negative 11x. So that means that this combination works. And so my final answer will be, and this is my final answer, as you can see. So it does, and we can test it out by multiplying it out. We see we'll end up with this answer. Okay, let's try another one. So let's say we want to factor this expression. And as you can see here, we have A is 15, B is 24, and C is negative 63. And as we deal with more larger numbers, we deal with complexity. But what you should notice is all of these numbers have a common factor, and that factor is 3. So if I want to divide out or factor out a 3, then this problem now becomes 3 times 5x squared plus 8x minus 21. And that's a much simpler problem to factor is 5x squared plus 8x minus 21 than 15x squared plus 24x minus 63. So we still have the 3, but now we're looking at two binomials that multiply together to give me 5x squared plus 8x minus 21. And so we go to our little big X method, as you can see here, trying to figure out what to put in these spaces so that we can end up with 5x squared plus 8x minus 21. So our A, as we can see, is 3. Oops, it's not 3. Sorry, our A is 5, and our C is negative 21. So A is 5 means A is a prime number, so we only have really one set of factors. But C is negative 21, which means we have two sets of factors. We have 1 and negative 21, or negative 21, I'm sorry, or positive 21 and negative 1. And we have 3 and negative 7, or we have negative 3 and 7. So we're trying to figure out which combination of these two will give us a positive 8. So we do know that since we only have A as a prime factor, we know that we can put in 1 and 5. But now we have to try and figure out which one can we put in of these 4 to get the positive 8. So let's just try 3 and negative 7. And when I try 3 and negative 7, I do my slide method, and my slide method goes something like this. 1 times negative 7x is negative 7x, and 5 times 3 is 15x. Add them together, and I get the correct answer of 8. Now, oftentimes, you randomly pick one of these combinations and test them until you find the one that works, and that just so happens I was lucky enough to be able to pick the first one that I picked worked. But if the first one you pick doesn't work, then don't get discouraged. Just start trying different other factors until you get one that works. But in this case, this one has worked. So now that I have my answer choice, now I can write the solution of factoring these two. So this is my solution, 3 times x plus 3 times 5x minus 7. And so that's what you're going to be doing in class. Just factoring by trial and guessing and using the big X method.